Seismic isolation is one way of keeping your building or bridge operational after an earthquake. What isolation is decoupling the building from the ground, and then the ground moves under the building and the building is largely unaffected by the earthquake. Hi, I'm Conrad Erickson, President of Dynamic Isolation Systems. We manufacture and design isolation bearings for buildings and bridges.
DIS, our core business is seismic isolation with lead rubber bearings, sliders. We also provide dampers and isolate floors for computer data centers.
We started out as predominantly being an engineering company that did some manufacturing. Now we're a manufacturing company with engineering support. This is our plant. We moved here in 2008. We have 60,000 square feet of manufacturing facility.
Hi, my name is Tan Tzu, and I'm a project manager for Dynamic Isolation Systems. This is our production shear test rig, and it was custom designed and built by DIS. As part of our quality control procedures, we production test 100% of our isolators that we ship all throughout the world. Testing itself will tell us how the isolators will perform in an earthquake.
We're always excited to look at unique applications. In fact, the majority of our applications are quite unique because isolation provides solutions that conventional design can't provide. A prominent building that people may know of is the Berry Street project in San Francisco, where we isolated at the top of a 3-story building so they could add 2 stories to the building. Yeah, the Utah State Capitol building was retrofitted with 268 DIS isolators. We've retrofitted a lot of the bridges, especially for Caltrans, so the Golden Gate Bridge, Richmond San Rafael Bridge and Coronado Bridges all are protected with our base isolators. We isolated the USC Hospital in Los Angeles and went through the Northridge earthquake in 1994. Had no damage, no interruption. The surgeons didn't stop surgery because they didn't realise there was an earthquake. So that was a real success story. DIS is looking at broadening into all markets around the world that have earthquakes. So we've got activity in Europe, South America, obviously throughout Asia. Here, these are some wall dampers that are being built for a new hospital in San Francisco. Over this way we have some slider plates that are in process. They're for a power station in New Zealand. Here we have some plates in process for a project in Japan. We machine all the surfaces of the plate. We have a plate here that's been machined for a bridge in Memphis, Tennessee. And we're finding that as time goes on, the awareness of people as to what the engineered solutions are and what they can have is growing, and there's more acceptance of looking at better performance. The newer design methods that are available mean that when you have an earthquake, your building should be basically undamaged. Historic buildings, iconic buildings, high priority buildings, they all need to perform during an earthquake. That's what we thrive on, solutions for high priority structures.